Hi, Mark.
Hey, David.
How are you doing today?
Good, how are you?
Good. So, where are you guys at? And, I mean, are you at a point yet where you can send me some problems that we can work on?
I just sent some to you. This was my homework that I had received so far.
Good. Let's have a look at it. Okay. So here's my two special triangles.
Okay.
And notice that in each of those triangles, they use my unit as their base. In other words, this is 1x, this is square root of 3x, that's 2x. You can take away the x and you get 1 square root of 3, 2. Over here, it's 1x, 1x, and square root of 2x. Divide everything by x, and you get 1, 1 square root of 2. So the x that they have added makes sense because what we're really talking about is the unit triangle or any multiple of the unit triangle. So what they've done is kind of cover all 45, 45 triangles and all 30, 60, 90 triangles by adding the x. All right. This is your homework for tomorrow?
Yeah, it's due tomorrow.
Okay, so you've done this one. I'm just trying to figure out what you've done. So this side is B, this side is A, that side is 18. So the similarity ratio is 9. So this short side should be 9 square root of, excuse me, this long side should be 9 square root of 3, which it is. Okay. That's pretty much the way you did this problem, is it not?
Yeah.
In other words, you divided 18 by 2x. But really kind of what you're doing is dividing 18 by 2.
Yeah, to find x.
Right. Okay, so let's have a look at the other one. Okay, so here our similarity ratio is 15, making that side 15 square root of 2. Do you have any problems on any of these?
There was, I think, one of them that was kind of, number 7 was not very nice.
Hold on a second, let me take a quick look at 3.
Okay.
Do we know this is a 45-45?
Yeah.
How do we know that?
It has equal base angles.
Excuse me. I was thinking that you wrote that in there. That was in the problem. That it was x and x. Okay. So that makes that 17 root 2. And that makes the similarity ratio 17 root 2. So we want to multiply it by root 2, and we get 34. Okay, let's jump to 7. What was written there? That's M?
Yeah, M.
M, N, and 12 root 3, right?
Yeah.
Okay, so you divide 12 root 3 by 2 to get the similarity ratio. You know, I wish they had another spot here that said SR. Because it's kind of only accidental that this ends up being the same as the similarity ratio. I mean, it's not accidental, but we're always taking that similarity ratio, multiplying it by 1 to get this side.
Okay.
Okay? So
Yeah.
that and the short side ends up always being the similarity ratio. That's what the similarity ratio is that short side. And then you multiply that by root 3 to get, what's 6 root 3 times root 3?
That I had a hard time doing.
Let's
I'm not
talk about those. In fact, I saw a bunch of problems in the book that looked like they would be good to go over. So
right.
when I have 6 root 3 times root 3, I'm multiplying 3 things together, that's all. Okay?
Mm-hmm.
And you multiply any 2 of them together first. So what's that equal to?
Root 9. Oh, okay. That makes sense.
Yeah, it is root 9, but what number is that equal to?
3.
Okay. Which means now 3 times 6 is 18.
Yeah.
Okay? Don't always remember that root x times root x is x. In other words, you don't need to say that's root x squared. Just know that the square root of any number multiplied by itself is equal to whatever the number in the radical is.
Okay. That makes sense.
So side n is 18.
Okay.
Number 8. This was the only thing given to you, right?
Yeah.
So that's the similarity ratio. And if we multiply that by 2, we get p. So that's definitely p. And q is this similarity ratio. Excuse me. 3 root 5 times root 3, which is 3 root 15. So you're good there. Only thing you need to fill in is this one. That's 6 root 5. In other words,
Okay.
this times this. Again, we can multiply any 2 of the numbers we want in whatever order. When you have a times b times c, you can do it in any order you want. So we're going to multiply the 2 times the 3 to get 6, and then it's 6 root 5.
Okay. That makes sense.
Okay. Just before we go on to these others, we won't forget those others. Just want to make sure you can do some of these radicals, because I saw a couple in here that look like they could be a little strange. I mean, as soon as I know you can do these, then we'll go back.
Okay.
What's that?
4.
No? In other words,
Oh, okay.
let's not guess. In other words, let's make
16 then.
Okay. Well, no, it's that times that. Right?
Yeah.
And again, we can multiply any 2 numbers together. We got 4 numbers being multiplied together there. So let's multiply that times that. That gives me 4. Let's multiply this times this. That gives me 2.
So that equals that to 8.
That's how you do that.
Yeah.
Okay?
Okay.
In other words, whenever you have a combination of whole numbers and radicals, just lay it out side by side like I just did. How about this one here? Yeah, let's make the numbers a little nicer. Let's make that a 3. Let's make this a 25.
Since it's in the, all that inside is going to be squared, wouldn't it not matter if it's starting out negative because it's going to end positively?
Only if the negative sign is inside the parentheses. In other words, what you said
Okay.
would be true if this were the problem. In other words, if that negative sign is inside the parentheses, yes, when I square all of that, I'm going to get positive. But it isn't. It's outside. So I have to square all of that, and then the negative sign is still going to apply.
Oh, yeah.
So what do I get when I do this? And basically, there's an easy way to do this. Square that, multiply the two together.
Yeah.
What do you get?
Is it 9 square root 225?
Let's simplify square root of 25 first. What's the square root of 25?
Okay. 5.
Okay. Now, 5 times 3 is 15. So,
Okay.
it's minus 15 squared. And
Okay.
that is minus 225.
Okay.
Okay. And
Yeah.
again, whether or not, whenever you see squares, it's only what's inside the parentheses that's being squared. If I write this, excuse me, the 3 is not squared because there's no parentheses. In other words, in this case here, the 2 only applies to what's immediately below it, which is an x.
Okay.
Okay? So this would be 3x squared. And if I put a negative sign in it, it's still 3x squared. Now, it's totally different if I do that. Now, what's being squared is the 3 and the x. So the 3 squares to 9, and now that becomes that. And
Okay.
if I had a minus sign in front of it, it would still be this. Because the minus 3 times minus 3 is plus 9.
Okay.
One more, and then we'll go back to the other. This is a little tricky here. I didn't quite write it like the book did.
Oh, yeah.
The only reason I didn't, the way the book wrote it was this way. In other words, they put the parentheses there. I didn't really feel like the parentheses were needed. In other words, to me, it's the same problem. This is identical to this. This 2 could only be being applied to what's below it, which is the square root of 9.
Okay.
So, with or without the parentheses, what's that answer?
36.
Yep. Okay, good. Let's go back and look at these geometry problems. What is R in number 9?
It's a leg.
What's its measurement?
Oh, 5 square root 6.
Okay, go ahead and write that in on your paper. And
all right.
What's S going to be?
S would be 5 square root 6 times square root of 2.
Okay, that's a good way to state it. I like that. 5 square root of 6 times square root of 2. Let's do some simplifying of that.
Okay.
What's that next step on simplifying that?
That'd be 5 square root 12, and then we can simplify square root 12 to 4, square root of 4, and square root of 3.
So the final answer?
Nope. We can simplify 4 too into just the number 2, and then we multiply 5 and 2.
So the final answer is what?
Is 10 square root 3.
Good. Okay. So that's S. And over here, what's T?
T would be 45 square root 2.
And what's U?
U would be 45, it'd be 90.
Good. Good. Is that barking on your end? I can never tell. It's either.
Yeah, that's just my dog. Let me close the door real quick.
Oh, well, no, it's not bothering me. I just didn't know if it was my dogs, if I needed to go check on them or anything. Okay, 11 is the first one that they give us this side here.
Okay.
So what's our first step on 11?
We want to find V, the short leg.
What's really our first step that I would like to see in all of these problems?
Simplify square root of 21.
No, the similarity ratio. In other words, what we want to do is we want to figure out what's the relationship between this and my special unit triangle. Well, how do I get that? Hold on. How do I get the similarity ratio?
I'm not sure.
Well, let me draw my unit triangle. This is 1, square root of 3, 2. Now, what is the similarity ratio mean? What does it mean?
The
ratio of the big triangle to the little triangle, corresponding side to same corresponding side.
Okay.
So what is that here? In other words, what's the corresponding side in our unit triangle relative to the only side they've given us here, which is root 21?
Square root of 3.
Correct. So what's my similarity ratio?
Square root of 3.
No. It's always the big triangle side divided by the unit triangle's side.
Okay.
So what's it going to be? In other words, that's what we were doing in all of these problems. It's just that we were always comparing it with 1. So they didn't feel the need to put an extra line in here saying, well, figure out the similarity ratio first. So the similarity ratio is what? Big to little.
Well, isn't it just square root of 3 because that's the biggest side versus the smallest?
No, here's what we're doing. We're not doing the biggest side of this divided by the smallest side of this. When I say big to little, I mean the big triangle, this one over here, relative to our unit triangle. Okay. And that tells you what the similarity ratio is, because every side on this triangle has to have that same ratio relative to this triangle over here. What is this reduced to? What does the square root of 21 over the square root of 3 equal?
Well, if you put it through that, that's 60, the square root of 63 over the square root of 9.
Where are you getting the square root of 63? Oh, I see what you're doing. Let's reduce this first. I want to make sure you know how to reduce this.
Okay.
What's square root of 21 divided by square root of 3 equal to?
Mm,
Remember what I do?
yeah, yeah.
Put both of them under. What's that equal to?
7.
Square root of 7.
Yeah.
Got to be careful not to lose the square root. That's an easy mistake to make here. So my similarity ratio is square root of 7. And if you like, I'll put a 1 under it, but I don't really need to. What I'm saying is that every side of this triangle is square root of 7 times every side of this triangle. So what does that make V?
V is square root of 7.
What does it make W?
It makes W 2 square root of 7.
Yeah. But in order to figure all of that out, we needed this similarity ratio.
Okay.
I think. I mean, I don't know. I mean, do they not talk about it? And how would they do this in your class if they wouldn't use, do they use the term similarity ratio?
Well, not usually, but
Yeah.
usually we just like,
Well, see,
if we're doing 21 over 3, we'll use 3. We'll set everything up like, it's hard to explain, but I think you know what I'm talking about.
Well,
maybe.
so you set up, you're going to compare, the concept that I really want you to get is that we're comparing this side here with any other 30, 60, 90 similar triangle.
Yeah.
And the one I'm going to compare it with is my unit one.
Mm-hmm.
So to figure out how big that side is, or rather to figure out W, say, well, I know that on my unit triangle, W is 2. So I need to know how much bigger this triangle is than my unit triangle. And I get that by comparing the only side they've given us, which is the side opposite the 60-degree angle, with that same side on the 30/60. And the side opposite the 60 is x root 3. See, the x tends to make it a little more confusing.
Yeah.
Because now you're dividing root 21 by x root 3, and it doesn't really make as much sense. But I think you get what I'm trying to say. Do you not?
Yeah.
Okay.
When we do it, we just like, if for instance square root 21, we'd set it under 3 and then cross multiply by square root 3. We'd set square root 21 over square root 3 and then cross multiply by square root 3.
I think you mean this. You don't mean cross multiply, you mean multiply that fraction by square root of 3 over square root of 3.
Yep.
The only reason I can do that is because that's the number 1. And I can multiply any fraction by the number 1 without changing its sign. And then I get square root of 63 divided by 3. And then I got to reduce that. That's square root of 9, square root of 7 divided by 3. And then that square root of 9 cancels with that, and I end up with that. But I think you can see that it's quite a bit faster to do it my way.
Yeah.
Don't go through this. This is called rationalizing the denominator. Okay? And it's one thing to use that if you were being asked for a final answer. But notice that I don't need to do that, because when I do this division, I immediately get root 7, and I no longer have an irrational denominator. It's not like there's any problem with that number. That number is perfectly fine. It's just not a final answer you would ever get.
I think the reason they have us do that is because if we ever get stuck with two numbers that don't perfectly multiply out, that's a good way to get it.
You're right. So, in other words, if I had square root of 21 over 2, let's assume that's our similarity ratio. Okay?
Okay.
say it was this, and then we couldn't use my little trick. But that would still be in my similarity ratio. Okay? And then the truth is how do I get this? Well, I multiply my similarity ratio times root 3. So now I have root 21 over root 2 times root 3. And now I have root 63 over root 2. And yeah, this is going to come down to 3 root 7 over root 2. That's not an acceptable answer for the side, v. So I would have to rationalize that. The only thing I'm saying is that don't rationalize until you have to, because it might be wasted work.
Okay.
In this case, I can't do anything. That's going to be my similarity ratio, square root of 21 over square root of 2.
Okay.
But before I fill in these answers, I'll rationalize it. If I end up with an irrational denominator, I'll rationalize it. But wait to do that. And in the last minute, what's x?
X is 9.
And what's y?
Y is 9 square root 2.
Good. Very good. Okay, it almost looks like you have skipped over, and you will go back to it, but this theorem 9.1, just tell me if this is true or not. For something we haven't talked about yet is this fairly significant theorem that actually, I can't believe they start off the chapter with it. I do not like that they start off the chapter with it. It's the hardest thing in the chapter. If you draw from the right angle an altitude to the other side, you create two triangles which are similar to one another. And in fact, not only are they similar to one another, they're similar to the original triangle. I have 3 similar triangles here.
Okay.
Have you covered that yet?
We haven't actually done many, we haven't even looked in the books so far with my new teacher.
Okay. Well, that's good. I'm glad, because I wouldn't want you to start off right triangles with this problem. This is a degree of difficulty harder. And the reason it is because these triangles, while one is similar to 2 and they're both similar to the big one, it's hard to see how they match up. In other words, they're oriented so differently from one another that it's not immediately easy to see what are the corresponding sides. And the way I do it is I always look for the side opposite. This is the smallest angle right there. So the side opposite the smallest angle is that one. If that's the small angle, that's the big angle, which makes that the other small angle. So this side right there is similar to that side. And I found it by finding the side that's opposite the smallest angle. And that's a little trick you might want to consider doing if you get to this material before next Tuesday. It's very helpful. Okay? All right.
Yeah.
Mark, I will talk to you next week. Have a good weekend.
All right. Thank you, Dave.